So, good morning, students. I'll start the class in 15 minutes, like at 1:15. So, you tell your friends to join by then. Okay, so good morning students. We'll continue again with our unit number 1, which is Introduction to Engineering Risk and Uncertainty and Risk Methods. Okay, so in continuation, the new topic is General Risk for Individuals. So as for the purpose of setting the scene in regard to the risk for individuals, considering the statistics that we have already discussed given in the table 1.2. So the table provides the observed frequency of deaths for a number of different causes and activities in terms of annual and lifetime probabilities representative for the USA. That is, with an average lifetime of about 77 years. So it should be noted that the probabilities are taken as an average overall recorded accidents and that the probability of dying due to a specific cause or during exercising exercising a specific activity depends on the behavioral characteristics of the individual. So, however, in comparison to diseases, that is the death rate, accidents play a very minor role. According to National Vital Statistics Report 2003, only about 4% of reported deaths in the USA are due to accidents, whereas heart attack, cancer, and stroke together contribute with 58% of all the deaths. So according to the report that is submitted by the National Vital Statistics Report dated 2003 for the year 2003, only 4% of deaths occur in the USA are due to accidents and the remaining 58% occurs due to heart attack, cancer, stroke and so on. So the numbers in table 1.2 which we will discuss now gives a relatively clear idea of the importance of different types of accidents and points to where and when fatalities occur more often. So this is your table 1.2, which is a comparative study of probabilities of death for different causes and activities. In here, you can see the different causes of death with the probability occurrence that is per year and the probability per lifetime. So different causes of death for transport accidents subdivided into pedestrian, pedal cyclist, motorcycle rider, car occupant, occupant of heavy transport vehicle, bus occupant, animal rider or occupant of animal drawn vehicle, occupant of railway train or railway vehicle, air and space transport accidents. Next is the non-transport accidents, under which fall struck by or against another person, accidental drowning and submersion, exposure to electric current, radiation, temperature and pressure, exposure to smoke, fire and flames, uncontrolled fire in building or structure, contact with venomous animals and plants, earthquake and other earth movements, storm, flood, lightning, alcohol, narcotics and hallucinogens, and intentional self-harm, assault, legal intervention, operations of war, and complications of medical and surgical care. Next is Table 1.3. In Table 1.3, the exposure to risk of the working population in the USA and corresponding fatality rates, that is the number of deaths per 100 employees, are given according to occupation sectors. So from the table, it is seen that the agriculture, mining, construction and also transport sectors are by large the most dangerous and that about 50% of the working force is active in these sectors. So now we'll see table 1.3, which is the exposure and fatality rates for the population for different occupation sectors, and this data is obtained from the Bureau of Labor Statistics of 2004. Here you can see the different occupation sectors and percentage of employees and the fatalities per 1 lakh employed. So in occupation sector for private industry, it is divided into agriculture, forestry and fishing, mining, oil and gas exploitation. It's not exploitation, it should be gas exploration. Then construction, manufacturing, transportation and public utilities, wholesale trade, retail trade, finance, insurance and real estate services. Next is government. For government, it comes under federal, which includes resident armed forces. Next is risks due to the hazards, natural hazards. The risks that occurs due to natural phenomena. So in table 1.4, which we'll discuss, it is then shown an overview of fatalities and insured losses due to natural hazards in the period from 1970 to 2001. And it is given based on the Swiss record, which is a record for 2001 data. So from the table, it is seen that floods, hurricanes, and earthquakes are dominating in terms of fatalities. So when it comes to fatalities for according to Swiss record, floods, hurricanes, and earthquakes are the ones that has caused the major fatality record. The insured losses only gives the indication of the economic losses. So the ones that is called insured losses, that is insurance losses, it only gives an indication of the economic losses. So in many events, most of the real economic losses were not insured at all. The nature of natural hazards is that they mostly affect a rather limited geographical area. Natural hazards has an impact or effect only on a limited topographical or geographical area. So even though in general statistical terms, the fatalities and direct economic losses may be relatively small as compared with other sources of death and the overall GDP of a given country, the localized nature of the events can be quite dramatic and have significant indirect consequences even much larger than the direct consequences. So in general, fatalities and direct economic losses are very small when it is compared with the other sources of death as we have mentioned earlier. And also, if we compare this fatality with the overall GDP of a given country, the localized nature of the events, that is the events which takes place locally in nature, it can be found to be quite dramatic and it has indirect consequences. And these indirect consequences are even much more larger or greater than the direct consequences. So safeguarding the individuals and the assets of society against natural hazards is a classical task of the engineer. So the basic or the main task of an engineer is to safeguard the individuals and also the assets of the society against the natural hazards. So here I have shown table 1.4, which is the insured losses and fatalities due to natural hazards in the period of 1970 to 2001 based on Swiss record. Here you can see the number of victims, then the insured losses, date of occurrence of such events, natural hazards, then the event that took place, the natural hazard that took place, and the country in where it took place. Basically, it is more of earthquake only. Volcano eruption and storm and flood is also there, but earthquake is more dominant. In some areas, there is also typhoon and tropical cyclone as well. Next is risks due to malevolence. So in recent years, yet another hazard has malevolence means hatred. So in recent years, yet another hazard has emerged and gained the attention of society, in namely acts of terrorism, also referred to as malevolence. Acts of terrorism, how it takes place, definitely takes place due to the hatred. So in table 1.5, the consequences of malevolent acts are seen to be significant both in terms of fatalities and economic losses. Same case here for table 1.5. Insured losses and fatalities due to hatred or due to malevolence in the period of 1988 to 2001. Here you can see the victims, also the insured losses of such victims along with the date of occurrence of such events, the events which took place and the country in where it took place. Next, as for the natural hazards, acts of malevolence are of a very localized nature and due to the circumstances of the events often have significant consequences. So in table 1.6, which we'll discuss now, the estimated economic losses follows the collapse of the World Trade Center, Twin Towers, and so are summarized. So in the table, So in the table, the scenarios low and high correspond to different models for assessing the consequences. However, it is clearly seen that the consequences go far beyond the direct losses of the buildings and the people inside the buildings. So actually, the total costs are in the order of 4 times higher than the direct loss of the buildings themselves. So consequence type, the scenario of the low and high ratio is given here. Estimated loss summary for the failures of World Twin Towers, which we already know about the World Twin Towers, the entire incident. Consequence type is rescue and cleanup. Property. Property includes WTC towers, other destroyed buildings, damaged buildings, inventory, infrastructure, fatalities, lost rents, and impact on economy. So the total loss that took place is 34.5 in case of low scenario and 91.6 in case of high scenario in USD, that is in billion US dollars. Okay, so this is all for this class. Next class will start a new topic. Now you can give your attendance in the chat box. Thank you. Those who have given their attendance in the chat box can leave this class. Those who have not are asked to give their attendance now. At the same time, tomorrow or day after tomorrow, I'll be giving you the weekly assignment. Thank you.